Cl2 plus H2.
Good job. So the reaction is going to be Fe dissolved in hydrochloric acid, HCl, dissolved, give FeCl2 plus H2. Okay. So look at the reaction carefully. 1 mole of iron produces what?
0.2, sir.
0.2. 11.2 grams of iron dissolves in this. Yeah,
Yes, divide by 56.
very good. 1 mole of iron produces 1 mole of hydrogen gas. So 11.2 grams of Fe. Now is how many moles is that? Given mass by molar
Molecular.
mass is what now?
0.2, sir.
0.2. 0.2 moles will produce. Is going to produce how much?
11.2 grams of Fe.
Okay. So in a closed vessel, first thing, work done when this thing happens in a closed vessel. Vessel is closed. Can the volume change in that?
No, sir.
Vessel is closed. The volume cannot change. Delta V is 0.
Work is also 0, sir.
Work done which is P external times your delta V. Since delta V is 0, work done will also be 0 by the system. So negative sign indicates work is done by the system. So W is going to be 0. First part is done. The second part is instead of the closed vessel, now it is in an open vessel. Same reaction, but in a closed, in an open vessel. What will happen here?
Volume can change, sir.
Okay. So what will be the change in the volume?
We can use the formula 2.303 nRT log, sir.
No gas is there initially. The closed vessel. Initial volume is 0 because there is no gas is formed. Okay. Take external pressure to be equal to 1 atmospheric pressure. Now, what will be the volume occupied by? How many moles of hydrogen gas is going to be formed?
2 moles, sir.
0.2 moles, yeah.
Yes, sir. 0.2.
right? And this whole thing is happening at what temperature it is given? Is it given 25 degrees Celsius?
298 Kelvin.
So using the ideal gas equation, PV is equal to nRT. Your V will be nRT divided by P, and P is 1 atm. Get the value of the volume to be equal to 4.89 liters. What is the change going to be?
Minus, sir.
4.
4.89. Sir, initially, why there is no gas, sir?
Reaction has not happened yet. Starting of the reaction, isn't it? Only
How?
the only the reactant are present. How will there be any gas?
Okay, sir.
At T is equal to 0, isn't it?
Yes, sir. Yes, sir.
We won't have no product would have been formed at T is equal to 0.
Okay, sir.
Now what is the work done going to be? Work done by the system because gas is formed external into change in volume.
Minus 4.89.
Liter atmosphere minus 4.89 liter atmosphere. Now to convert this into joules, multiply it with 101.3 joules.
What, sir?
Minus 4.89 into 101.3 joules.
Okay, sir.
Which will give you 490 minus 495.4 joules is the work done in case of open beaker. Same reaction takes place in open beaker. This is going to be your work done. Okay.
Yes, sir.
All right. Okay. So, Jonathan, getting any hold of it? Does it seem to
Not,
be
not really.
not really? See, actually, so far, whatever we've seen is very simple only. Goes with the concept of when I have a system. Okay, imagine what happens when. Let's take the case of a bottle or a simple bottle, a closed bottle. Let's say I'm going to take a closed. Now, it inside I have some water, whatever that is. What let's say even water is. Now, when you try to crush your hand, when you crush this, what will happen? What will happen to the, let's say, the pressure inside is P1, the pressure outside is P external. So if your external pressure, when you're crushing it, the bottle is going to experience more pressure than the internal pressure, isn't it?
Yes, sir.
Yes, sir.
So in this case, what will happen?
Compression.
Compression will take place. or no?
Yes, sir.
The bottle, will it compress or will it not compress?
Uh,
What do you mean by
it
compress?
will compress, sir.
It will compress, huh? Will it or it will not?
It will.
It will.
Compressor.
Yes, it will compress. On the other hand, you take a balloon. Okay. Now you keep blowing. You extra. Now as you keep on blowing, the air keeps hitting the walls of the balloon. So what will happen to the pressure at these places compared to the outside pressure?
Internal pressure will be greater, sir.
There will be more pressure experienced by the walls of the balloon compared to the outside. So it will go to the extent of even bursting. So in this case, what is happening? Is compression happening or expansion happening?
Expansion, sir.
Expansion is happening.
It's
So what work done? What do we know about work done? Work done is what? Force into displacement, isn't it?
yes, sir.
Right. Now force is considered to be a quantity of intensity, and displacement distance is not going to be a thing of intensity. How much it is expanding is going to be that of a capacity. Okay. Now, what is the relationship between pressure and force? Pressure is equal
Pressure
to
is
what?
equal to force by area, sir.
Force by area. So what will be F is equal to P into A, right? So work will be P times A times dx. Now what is A into D going to be? A into dx. Area times the distance. Suppose this is the area,
Yes, sir.
and if it is changing by a distance, this much distance, it's expanding by a distance of delta x. Let's say this is the area A. What is this A into delta x going to be? Call it. That is how this work done becomes P times delta V. This
Yes, sir.
expansion or compression takes place. How long does it take place, Jonathan? Expansion or compression?
How long it takes place?
How long? Yeah. Does it even stop or does it not stop?
It stops.
It stops. It stops, but when does it stop? Does it stop immediately after bursting or
Immediately after bursting.
after bursting it will stop? Uh-huh. So this process will go on until the pressure outside and pressure inside is going to be equal.
Zero. When adiabatic, sir.
Yeah. So when it reaches a point when both the external and inside pressure are equal, that is when this is going to stop. Okay. So that is work done will be carried out until outside and inside pressure are equal times delta V. Now see when it is compressed, when you are compressing, when outside pressure is more, what happens to the direction of the piston? Will it move downwards or will
Downwards.
it go upwards?
Downwards.
Even on the, I think Jonathan is wondering, why should I even take a piston? What is this?
No, sir.
See, Jonathan, double idea. See, look at this. Now, what I'm saying is, assume you have a a container with the frictionless piston. Okay,
Okay.
frictionless piston is kept here. Now, if I put more pressure here outside, what will be the direction of the piston? Will it go downwards or will it move
Downwards.
upwards? Uh,
Downwards.
it is going to move downwards. So the piston is going to come here, isn't it?
Yes, sir.
The piston will come here downwards. So that means what is happening? Compression is happening until what point? Until the external and internal pressure are equal.
Mm. Mm.
Okay. It will
Yes, sir.
stop at this point. Now this
Okay.
change is going to be the change in the volume.
Yes, sir.
Understood? This is what we
Understood.
this is what we were saying the last few days and trying to understand the terms and what are all the terms involved and all that.
Okay, sir.